Hey math kids, today we're going to continue our discussion with completing the square. So we're still in 2.BB. We're on day 3 this time, and our goal is to turn something that's written in a quadratic that's written in standard form into something that looks like this, which is called vertex form. So we're just transforming these into these. Now the benefit of this is that the vertex of the parabola is at h comma k. And so if we graph it, we say the vertex is at 1, 1. That's what h and k would be. So it would end up being x minus 1 plus 1. Now there's also a scaling factor right here, which we'll talk about in just a little bit, but that's the idea of it. Okay, so now we're going to move on to an exact problem. And I think we're going to start once again with the problem we've started all these series of videos with. So hopefully you're feeling comfortable with this one now. So I'm just going to go through completing the square again, but I'm only going to go up through the steps that I did on the first video, because then we're going to take a different route with it. So this is quadratic, so I can set this equal to 0. I add 1, add 1. I'm going to go kind of quickly through this. So if you're not comfortable with completing the square yet, maybe watch the first 2 videos that are related to this one. We don't need to divide by anything because our a is 1. So we do our L step, we divide by 2, get 1, we square it, get 1. So we add this 1 to both sides. This ends up being 2, x squared plus 2x plus 1. We do the magic step, we write a variable, come to the elbow. Okay, and then that's where we stopped on day 1 of the video, and that's where we're going to stop and then do something different. So we're not gonna solve for the x. Now what we're gonna do is we're gonna move this onto this side, and we end up getting y equals x plus 1 squared minus 2. Now, to prove it to yourself, I'm going to graph this. I think I'm actually going to use Desmos instead. So you just go to desmos.com. Try to move this into the screen. Okay, so desmos.com, and the original was x squared plus 2x minus 1, and then the one that we got was x plus 1 minus 2. Okay, so it's going to be x plus 1 squared minus 2. Now see, I'll move this over. These buttons right here will turn off one or the other. And so we can see that they're the same. So I'm just going to keep changing those. I know you can't see me pushing the buttons. So I'm turning off the blue one, turning off the red one, blue one, red one. They're the same thing. Okay? Now, we can be confident that that's the same thing, whatever, this process gives us, if our a is 1. So in this case, the a value right here, it's a ninja 1, and so this is all we have to do to get the vertex form. Now, it specifically asks us where is the vertex. So remember, it's h comma k. So we actually changed the sign right here, so it's going to be -1, and and then we keep the sign right here, so it's -2. So let's check that out on the Desmos. Right here, it's -1, -2. If you just put your cursor over the vertex, it will tell you what it is. Okay? Alright, let's do another one. This time we're going to do one that the A is not equal to 1 and show you what we need to do. So we have, let's say y equals 5x squared minus 50x plus 15. Let's try that one. Okay, so it is quadratic, so we can set this equal to 0. We subtract 15. So -15 equals 5x squared minus 50. Because our a term is not 1, we need to divide everything by the a term, which is 5. -3 equals x squared minus 10x. Now we do the L step. Cut this in half. We get -5. Square it. -5 times -5 is 25. And that's what we add to both sides. Okay. I'm going to move over here. So 25 minus 3 gives us 22. So we get 22 equals x squared minus 10x plus 25. So 10. Okay, this is where we do the magic step. So we have 22 equals these parentheses being squared. Put the variable in. And then we take the elbow step, which is -5. Once again, this is where we stopped on the first video. So if you have trouble with this, getting to this point, maybe rewatch the first video. It goes a little bit slower through this content. Okay, now what we want to do is we want to get this onto the other side. So minus 22, minus 22. And so we end up with 0 or y, because we're going to change the 0 back to a y. Or no, let's keep it, we want to keep it 0 just for a second. So x minus 5 squared minus 22. So I'm going to make the case that this is not the same thing, but I'm going to just show you that it's not. So let me enter the original. So the original is right there. So it's 5x squared. Oops. 5x squared minus 50x plus 15. And then our answer, okay, so let's look at this. Okay, so we can see that obviously the blue and the red are different. So the issue is we actually need a 5 out in front here, but we can't just magically put a 5 out in front. So what we're going to do, we're going to use algebra. We want a 5 right here, so we're going to multiply by 5, but that means that we also have to put a 5 to balance this out. So the question is, do we multiply by 5 or do we divide by 5? And so going back here, let's test it real quick. So I know I want a 5 there. And so do I do 5 times? Yeah, that's what I need to do. So I need to also multiply that by 5. I'm going to zoom out and then turn off the blue and the red, and we see that we get the same thing. And so 5 times 22, we go to our calculator. 5 times 22, we get 110. So just to make that a little bit nicer, that's what we'd end up with. So just to recap that real quick, we do what we did on the previous problem. So we subtract the 22 over here, and we have this. But whatever our leading coefficient was. So in this case 5, we need to multiply everything by 5. So how that's going to show up is we multiply both pieces right here by 5, and so our final answer is going to be 0 equals 5, x minus 5 squared minus 110. And then just like in the beginning how we changed the y to the 0, we can actually change the 0 back to a y. And then if it asks for the vertex, we pull out this, changing the sign. So 5, it's negative, but it's positive down here. Then this one, we keep the sign. So our vertex should be at 5, negative 110. So let's check that on Desmos. So if we hover over 5, negative 110, and so that holds up. If you need additional help, please come to Math Lab. Until then, calculator.